How does chunking help working memory? Chunking is the organization of smaller pieces of information into larger groups in order to increase the capacity of working memory. Across 4 experiments, they attempted to answer 3 questions within the article. 1. Does chunking reduce the load on working memory? 2. Is the chunking benefit independent of chunk size? And 3. Does the chunking benefit depend on the serial position of the chunk? The results were that a chunk does reduce the load on working memory. It is through the retrieval of a chunk from one's long-term memory that replaces individual components of the chunk, which frees up capacity for subsequently encoded information. Why is the article interesting? The article provides an explanation as to why chunking is so effective as a means of remembering various pieces of information. The article goes beyond this idea to provide answers as to why this is, and if manipulating the size and position affects its ability to do so. Why is it important? This article can provide information on how to better use chunking. It has proven that chunking is effective in remembering information, but it can be improved. The first experiment, lessening the load on working memory through chunking. What was being tested? They tested the idea that the load on working memory would be reduced in the instance that a chunk would be included in the memory set. What did they expect the outcome to be? It was hypothesized that this would improve the recollection of information that wasn't chunked but provided with the chunk. The method. Participants were 20 university students, 15 being women and 5 being men, all averaging 25 years old, and they had taken part in 2 one-hour sessions. The procedure was that participants sat at a computer and were tested in individual cabins. Of a pool of 338 nouns, 24 were randomly selected from this pool. 12 nouns were used as singletons to construct new lists from, and 12 nouns were used to construct 4 chunked lists, 2 chunked lists with 2 nouns, and 2 chunked lists with 4 nouns. They were used as 16 sets to be learned in a training phase. The results were that in the serial recall of new lists, recall accuracy of new lists does not differ as a function of chunk size. There was strong evidence for the assumption that chunk size has no influence on how much capacity a chunk requires in working memory. Serial recall of chunk lists resulted in that chunk lists were recalled with a very high level of accuracy and remembered better together with another chunk than with a new list, and better together with a list of size 2 compared to a list of size 4. There was no evidence for a main effective size of the current chunk to be remembered. The discussion explains that the experiment used a training phase to establish chunks of different sizes, 2 or 4 words. It showed that storing a chunk reduced the load on working memory. It was easier to understand a list of random words when another list to be remembered concurrently was a chunk instead of another random list. The data also supported the claim that working memory capacity is constrained by the number of chunks and not by chunk size. Increasing the size of a chunk had no influence on remembering a random list of words when the random list was recalled first, whereas increasing the size of another random list did impair recall. There is a chart of critical results that described how it differentiated with a size test of 2 rather than a size test of 4. The recall of new lists with 2 items is on the left and with 4 items is on the right. Performance is plotted as a function of the size of the list, 2 or 4 items, for the 2 types of lists, new list or chunk. Why are these results important? These results are important because it shows that chunking a list can not only help you to remember that list, but also to remember a non-chunked list at the same time, giving us more space in our working memory. Are there problems with the theory or with the experiment? The sample size is a little small, being only 20 participants, and only shows results for university students aged around 25 years old. Their memory potentially may be better than older participants and those not in university. What are the limitations? This experiment only shows results for university students. A possible real-world implication of the results. This experiment could help university students in studying, working professionals such as doctors when trying to remember definitions, or chefs when trying to remember different recipes. Aside from working professionals, it could help everyday laypeople in remembering items, such as grocery lists or helping the elderly when their capacity for memory begins to fail.